Welcome back everyone. In today's class we are going to solve a classic question from one-dimensional motion which has a little bit of calculus in it. So let's give it a try. As you can look, the question is said that the position of an object moving along the x-axis is given by an equation where a and b are the respective constants. Time t is measured in seconds, as you can observe. We need to calculate the velocity of the object at the time 0 seconds, that is when the body started, and also we need to find the velocity of the object at time t is equals to 2 seconds. Whenever we are being asked to find out the velocity at some instant, then we are dealing with instantaneous velocity. Similarly, we will have to find the average velocity between the time 2 seconds and 5 seconds. Okay, so let's give it a try. As you can see, we know that by the basic rule of calculus, velocity of an object is the derivative of the function x. We already know that the value of x is equals to 2a plus half bt square. The equation is already written here, so we need to differentiate it one time. After differentiating it, we have v is equals to ddt of 2a plus half bt square. Now as you can observe, 2a is a constant term and derivative of a constant term is equals to 0. So that's why it is 0 here. And similarly, let's move on. Derivative of half bt square will give us half b, which is again constant, and ddt of t square will leave us with 2t. So velocity of an object at any instant of time when the object is following this equation, then we can say that the velocity, the instantaneous velocity of the body or the instantaneous velocity of the particle throughout the motion is given by the equation v equals to b times t, where b is the constant. The value of the constant has been stated to be 2 meter per second square, and in this case we have seen that this is a time dominated equation. Obviously velocity depends upon time. So let's put the value of the velocities here. You know that we were required to find the velocity of the particle at time t equals to 0 seconds, that is at the start, and also we were asked to find the velocity of the particle after 2 seconds. So at 2 seconds, if we put the value of t is equals to 0 in this equation, we end up with 0 meter per second. Yeah, you should write the units also. And similarly, the instantaneous velocity after time t is equals to 2 seconds, we have b times t. B was equals to 2. So we have the velocity of the particle as 4 meter per second. Now moving on, how to find the average velocity of the particle. That's a very simple formula. Average velocity is equals to displacement over time. So we need to find the displacement of the object. In order to find the displacement of the object, let's write down the formula. Average velocity, obviously the time interval plays an important factor. Okay, the average velocity in the time interval t is equals to 2 seconds and 5 seconds has been written as displacement after 5 seconds minus displacement after 2 seconds divided by the change in time interval, that is delta t. 5 minus 2, so we end up with 3 here. So let's solve it. We need to find the displacement of the particle after 5 seconds. How will we find it out? We already have a solid equation at the start. So as you can see, xt, distance, is a time dominated equation. So we have 2a plus half bt square. We are simply going to put the value of t as 5 once. By doing so, we end up with 35 meter. That is, after the end of 5 seconds, the displacement of the object is 35 meter. And similarly, if we put the value of time as 2 seconds in the main equation, that is this equation, then we end up with the displacement of the particle as 14 meter. Fine, so we have find out the displacement of the object after 5 seconds, and we also have the displacement of the object after 2 seconds. Now if we take a look at the formula that we have written above, the displacement of the object, we know the displacement of the object after 5 and 2 seconds, we have the values. So we just have to plug in the values in order to reach the answer. The result is there, 35 minus 14, that is we end up with 21 over 3. So that's give a final answer of 7 meter per second. Hence the average velocity of the particle during the time of motion from 2 second to the 4th second was 7 meter per second. That was a very simple question and very easy way to solve. Thank you.